Hello, and once again, good evening and welcome to our series of webinars in association with the Trade Association. Tonight's webinar will be on the EICR codings and on the inspection schedules. Tonight, myself, Paul Markham, is joined by Gareth Davies. We're going to take you through the presentation. There should be some time at the end for some questioning. So please feel free to ask the questions on the function button. Please do that. We'll do our best to get through as many of the questions as we can. You will also find in the panel a full copy of the presentation in the handout section on the control panel. There's a certificate of attendance that you can download. You can obviously download and have a look at the webinar on YouTube a bit later on. We'll leave a couple of minutes at the end of the session to give you time to download all the handouts, etc. There'll also be a short survey, so please do complete the survey and make sure that we can have some feedback on these webinars. It's essential to us. So without further ado, we're going to start the presentation. Tonight it is on the EICR inspection schedules and codes. The reason for a periodic inspection and test. Why do we do periodic inspection and testing? The fundamental principles of BS 7671 is the safety of persons and livestock against the effects of electric shock and burns. So what we're doing is attending and making sure that nobody within that property can still have any problems with electric shock, fire. We're making sure property cannot be damaged from fire. We're making sure that any damage or deterioration that's happened over the lifetime of the installation so far can be observed and recorded. We're also making sure that there are no defects and non-compliances with the current edition of BS 7671. It is the current edition. We always work to the latest copy. Basically speaking, as it's underlined at the bottom, is the installation safe for continued use?
Okay, so why is it necessary then for a periodic inspection and test? Now then, there's quite a few reasons. Largely because of legislation. The electricity at work regs requires it for any installation to be maintained in a good condition. There might also be licensing authorities, some public bodies, insurance companies, or even if you was changing mortgage to a new lender, these might be requirements from them to check that the electrics are still in good working order. There may also be additions. Where there might have been changes to that electrical system over time that's not noted on the EIC, and so it's a good way just to check what might have been changed and just to prove that that circuit is still in good working order.
Looking at the requirements of BS 7671, it's a two-stage process. We call it inspection and testing because that's what we do. We inspect first and then we test. Inspection is probably the main body of what we do. It is, as guidance note 3 states, a detailed examination of the installation with little or no dismantling. That would obviously depend on the inspector's judgment, what the inspector finds at the time, how much they need to investigate. The testing process is done after the inspection just to back up that inspection and to ensure that the installation is safe for continued use.
Okay, so one area in particular then we'll look at is the rented domestic and residential accommodation. Now then, the Landlord and Tenant Act 1985 requires that rented property is safe when a tenancy begins and also maintained in a safe condition throughout the tenancy. However, there was no specific mention of a need to carry out an EICR in the Act, but carrying out EICR would be a practical way of identifying where any remedial work was required to keep the installation in a safe condition.
The inspection schedules that you find attached to the EICR and sample checklists that are provided within guidance note 3 provide us with lists of items to be checked during a periodic inspection. Although the lists are extensive, not all items have to be inspected when you're doing the periodic inspection. And the lists do not include all the items that may require inspection. What happens at the end of that inspection is often a difficulty in determining what defect codes we should be applying to the observations that we have made.
Okay then, so before the 17th edition, Amendment 1, introduced the EICR and the new inspection schedule. There was not a checklist of items to be inspected. While this may have created a few more pages to complete, it has made the process of periodic inspection a step-by-step procedure.
What we have in front of us is the NAPIT's stance on an electrical installation condition report. The main document, of course, is on the left-hand side. And the inspection schedule that we're discussing is there on the right with a list of items to be checked. As you can see, we start on the distributor's position, moving on through the earthing and bonding arrangements, consumer units, distribution boards, through to the final circuits, all the way ending at special locations. What has made the job a little bit easier in this case is having next to the items to be inspected and the description, the regulation numbers themselves, so at least you can refer to the BS 7671 and know what we're looking at.
Okay then, so on your inspection and test then, should you come across anything that's not quite to good standard, then we can give him a code. Now then, we have had some debate about this through some members, however, these are the codes we have to work with. Okay, so should you have come across something where danger is present and there's an immediate risk of injury, then remedial action is required, so we'll give that a code 1. Now then, should something be potentially dangerous, then we would give that a code 2. Yes, it still needs action, but it's not immediately dangerous. Now, should something not be quite up to standard, it's not dangerous, however, it still needs improvement. So something that's not great, it's against standard, so we'll give that a code 3. Now then, we also have further investigation. This is for a type of circuit where we can't actually determine if it's any good or not, so there would be further investigation required. But it is important that should any code you come across, that in your observations you are very specific and describe it accurately, because at the end of the day you're going to be giving this to a customer, and you know it helps them to understand why you've given it a code.
How do we determine a defect, and how do we select the correct observation code to put next to that defect, and what action do we take when faced with an observation code? We've mentioned C1s. The C1, as it says in the regulation, is immediately dangerous. To me, it is always death if you touch it, if you like, and therefore C1 would be an instant unsatisfactory result on the EICR. C2, potentially dangerous. There has to be something happening within the installation that causes that to be dangerous. In itself, touching it will not cause injury, but if something happens with installation, you get a fault, then that is when injury will occur. A C2 again is an unsatisfactory result. Further investigation. A fairly new code that came in. It isn't that there are new problems within electrical installations. I've been doing this job many moons now, and further investigation has not been in my vocabulary, but now it is. We have to use it. Further investigation is for something, in my opinion, such as a circuit can't be identified what you're actually switching off when you're isolating. It can't be switched off. You don't know what it's switching off. You can put down further investigation. These three codes on a periodic inspection and on the EICR would mean an unsatisfactory result. C3 is improvement recommended. Minor problems. Problems in the fact that it doesn't comply with the regulations, it's not within the regulations, but in no way does it make the installation unsafe. and also you can put down an observation, something that hasn't got a code, but something that you've noticed and that you can put down just to bring to the attention of the customer. If they wish to do anything about it, they can do.
Okay then, so let's have a bit of a look at something here then. So here's a picture of an installation that one of our members found. So in this image, in this consumer unit, meter tails have been installed. So what it is then, we've got some tails which are over 15 meters in length from the service cutout views. It's also within a metal framed plasterboard walls and ceiling. There's no support on the cables, they're quite loose. And with no reinstatement of the fire protection where it goes through that ceiling. So what do we think here then?
We've got a few problems with these. Obviously we're looking at section 1 on the EICR inspection schedule. We're looking at the condition of the meter tails and the distributor's equipment. And although we personally cannot do too much about it, we do have a duty to give the information to the customer that things need to be done. The installation as a start was really incorrectly certified initially. Therefore, during the EICR, we need to report on these conditions. To me, the overall coding would be a C2. There's a few problems. They all add up to a C2 code. First of all, with the length of the cables, there's no overcurrent protection for the cable. It exceeds 3 meters, and a separate switch fuse would need to be installed at the origin. There are no mechanical protection against the sharp edges of the metal frame. This cable should have been installed originally with some type of earth metallic covering or RCD protection. The cables again are subject to movement, which can affect the terminations, cables twisting within terminations, becoming loose, producing heat, etc. And with no fire protection within the holes that the conductors run through, any problems that do cause a fire would definitely spread very, very easily.
Okay, so let's have a look at another one then. So here we are then, looks like a fireman's switch outside. Okay, looks like there's a big hole in it so I can get my fingers in, and there's no labelling either to indicate what it switches off, what it switches, what it does, what's it used for. So what do we think about this?
Again, a couple of points that really have come to the conclusion that it is in a dangerous condition, and a C1 would therefore be attributed to this observation. It is obvious with the hole in the front of the isolator that people could put their fingers in. In fact, in that one, most of the hand. Access to live parts. If those live parts are touched, obviously injury will be on the cards. So immediate isolation is required. You need to get in touch with the customer, tell them what you're going to be doing, make sure that they are aware that it's being isolated and what grounds you're isolating it. The isolator also, as Gareth mentioned, didn't have any labelling installed. If this was the only issue and the hole wasn't there, then you could quite safely put down a C3. The label itself doesn't mean that it's unsafe, but with the hole and the label not being there, an overhaul C1.
Okay, so here's another one to look at then. I'm sure many electricians out of you there have come across this before, where it looks like a socket has been either overloaded or the cables on the back might be loose, and it's obviously caused some sort of damage there through an excess of current coming through that terminal. So, like I say, yeah, either loose connections, however, it is most likely that the appliance that are being connected, it's just drawn too much current through it.
Again, an overall code of C2. Touching the socket itself will probably not kill anybody. It is not immediately dangerous in that respect, but the right hand socket cannot be safely used. It is showing signs of thermal damage. Using it more and more and more, this is not going to get any better. It will only get worse. Using the only socket available on the left will mean it could be used with extension leads, extension cubes, meaning the overloading could be even made worse.
Right, so here's another example then. Let's have a look at this one. So what we've got here are singles cables installed in trunking. There's a hole in the side and the trunking lid is missing. So what do we think about this?
Again, if we look at our inspection schedule under section 5, we've got containment of cables. And the containment is in a potentially dangerous condition. With everything all told, the overall coding will be a C2. We do have single insulated conductors which can be subject to damage. Again, this can be open to interpretation because it would depend on what could cause the damage and maybe how high the trunking is. But those conductors could definitely be damaged by something being inserted into the trunking. Without the lid, we've got a possible spread of fire. If anything happens, the ingress of oxygen would increase the fire risks. And of course, the removal of the section has only left sharp edges that conductors could come in contact with and therefore make the whole installation into a dangerous situation. The lack of space within the containment, if that was the only problem, would probably have then been put, or could have been put down as a further investigation. It would need to be investigated. You would need to take a load of the what was on the cables. You would need to take into account the factors for the trunking and the conduit, and therefore you would need to take that into consideration.
Right, okay, so let's have a look at the next one then, if we can see it. Right then, so here's a bit of a tricky one here, quite unusual. We've got some sort of emergency shower by the looks of it, but also within the vicinity there's a big control panel. So what do we think about this? So as you can see, yeah, there's the shower, yeah, there's some control valves, there's the control panel, so you've got water very close to electricity here.
It's obviously some type of commercial industrial situation. It is an emergency shower which is often used for these situations where you could get covered in chemicals, acids, alkalines and the like, and they're used to douse you down to cut down on the burns. The problem is it's been installed or the switchgear has been installed after in this place, and of course it's given us this potential shock risk. Overall coding must be a C2. There's obviously a risk of electric shock for anybody using that shower, and as it's for emergency use it would only be a C2. Nobody would probably use it for general use, but if it was in general use then it would obviously be a C1 and dangerous all the time.
Okay then, so here's one we've all come across before. It's a installation of a certain age. You've come across this type of cable, and on the CPC there happens to be just a only green sleeving. So what do we think about this?
It's just an example of non-compliance. It doesn't really rate a code. It doesn't present a danger in any way, shape or form. The CPCs are sleeved. The user won't come in contact with any part of that installation. If an installer was carrying out work and happened to be colourblind, admittedly they could get red and green conductors mixed up. But no conduct coding in this instance. Personally, if it was me, I'd always put an observation down without a code. And again, there's no real need to change the green sleeving to green and yellow. If somebody was doing work on it and it was convenient, then no problem. But other than that, just a non-compliance.
Okay, so let's have a think about some of the bigger issues that I might come across. So before the Third Amendment then, a lot of the boards were of a plastic construction, non-combustible. So just because you come across one of these, it doesn't necessarily mean that you have to give it a code, but it does mean we have to check them over. So we have to check them for sort of thermal damage. We have to check that the cables are nice and tight, the buzz bars are nice and tight, and that basically it's doing its job the way it's meant to be doing. There's no damage to the enclosure, and so should everything be good with it, then there's no need to put a code. However, should we find that there is some sort of damage, whether it be thermal or that the containment is damaged, then we would have to give it the appropriate code. So maybe a C1 if the you know, if you could get your fingers in, so IP2X, to maybe C2 if it was starting to show a little bit of heat damage. However, if a consumer unit is metal and the metal cover can't quite fully close, then you maybe give it the appropriate code.
On sockets, a lot of questions asked on sockets and whether a socket needs RCDs on it. BSM 671 states that any socket up to 20 amps requires RCD protection, but of course previous installations were not wired or installed to those standards. If a socket outlet could be used outdoors and it doesn't have any RCD protection, that would be a C2. Come the summer periods, if we ever get a summer period, then people go out for the barbecues, have friends round, extension leads, music, whatever. How do they cut the grass? How do they cut the hedge? Is it with an electric trimmer? Then that would be C2. Socket outlets within a dwelling that haven't got RCD protection and cannot be used outdoors, then we could just code that down as a C3. Not inherently dangerous. We're not going to use it in a dangerous situation. And as long as we can't see problems with socket drops and cables having very close proximity to holes and kitchen units being drilled, then C3. We do have socket outlets in commercial and industrial where we don't, at this present moment in time, need RCD protection. But we do have to have a risk assessment that's been filled in, and that risk assessment should conclude, not on cost grounds, that there doesn't need to be an RCD, with the fact that we have competent, semi-competent people there working with these sockets and they are aware of the dangers. But if there's no risk assessment, it would be a C2. Other areas, dwellings, no RCD protection, but we have a specifically identified piece of equipment. Again, we would need to make sure that it was just for that piece of equipment and no other. If it's just used for a particular piece of equipment, satisfactory, and if it's used for other things, C2, because it's inherently dangerous. Within bathrooms, rooms containing baths and showers, if there are socket outlets with no RCD, it's going to have to be a C2. Socket outlets within 3 meters of the edge of the bath, zone 1, again C2. And of course, if you've got caravans and marinas and the sockets within those have no RCD protection, we would need to code those as C2s.
Now, something that's come to light in recent years as well is the cable supports in escape routes. Now then, if you've got cables going through an escape route, then should there be a fire, for instance, then those cables still need to be supported so that they don't drop down, impeding people's escape or entry into the building. Okay, so should you find then that there are cables that aren't supported adequately and they can drop down in a fire because they're only held up by either plastic tie wraps or a bit of plastic conduit or plastic trunking without the adequate support, then you're going to give them a C2.
The lists that we've just seen, or the lists that are on the screen at the minute, are what our technical committee goes through at regular stages, and to be quite honest, we're coming up with these codes for future reference to include in our publications and in our circulars on the internet and through your email addresses. What we'd like to do now is just go through a few issues, a few photographs that a lot of our members do collect and send in to us. And we'd like to see if you, through a poll, can give us the codes on the following. So if you'd just like to have a look at our obvious wireless consumer unit, if you'd like to have a look at it and see what type of poll you would, or sorry, what type of code you would give us for this type of installation. So the poll's open at the minute. If you'd like to enter into your panels how you think the the issue in front of you should be coded. We'll just give you a few more seconds on that one. Yeah, okay, most people have concluded, and quite rightly, a very, very large majority is that this is a C1. Obviously, the bus bar at the bottom is exposed, the fuse carrier is not there, the circuit breaker is not in place. It's a C1. To me, it would probably be even a C1, even with the tape on the right-hand side near the main switch there, because again, somebody could easily push that in and put the finger onto a live connection.
So here we go. Here's another instance. I'm sure we've all seen this type of thing before. We've gone to a property with an installation of a certain age. There's a socket outlet that has been damaged to such an extent that yes, it's going to need replacing. So if you come across this, what would you give it?
Yeah, we're going to close it now. Pretty good swing onto people voting mostly for a C2 there, which I find, personally to me, it's got to be a C1. It really is. There's a sort of 2/3 saying a C2. What we've got surrounding the obvious distress to the socket is packing tape. Packing tape's nowhere near PVC tape, and PVC tape wouldn't be thick enough on one coating to provide protection against electric shock, against somebody pushing against the contacts within there. That would definitely be C1. It is a danger to life, and therefore should be coded as such.
Okay, so here's another picture then. We've got a bit of terminal block wrapped up in a bit of PVC tape. So what do we think about this?
Launching the poll now, if you'd like to have a vote. A few more seconds. Fair enough, we're going to close it now. Again, interesting. A good few people out there on C2s. I'm afraid PVC tape is not an enclosure. We all have PVC tape in our toolboxes. I know, yeah, it's still in mine, even though I'm getting old in the tooth. It is still there, and we use it for a multitude of things. But as an enclosure and protecting people from live terminations, I'm afraid it's just not thick enough. It's made of insulating material, but it's not thick enough to give us that insulating property that a cable sheath would, or an insulation. So therefore, to me, that's a C1.
Okay, so let's have another look at another one here. So it looks like there's some sort of fuse carrier on the neutral, perhaps, as well as the live. Yeah, it's open. So what do you think about this?
Poll is open. If you'd like to code this one. Right, we're going to close that one. Yeah, there's a good swing on the C1s there. I mean, at the end of the day, obviously the front of the very old metal-clad switch fuse is open. You've also got a switch fuse at the bottom. You've got where the screws hold in the contacts on the reverse side of the porcelain fuse holder there. You've got one missing on the bottom left. You've got cables within the metal consumer unit that are obviously new. You've got cables within the unit which are very old vulcanized rubber insulated ones. For some reason you've got 2 line conductors and 3 neutral conductors, and probably no protection in the holes where these cables come from. Yeah, it's dangerous. To be quite honest, it's the start of a rewire, but yeah, no problem with that.
Right, so here we go. We've all seen this type of thing before. Looking at a gas meter, look at the earth on it. You know, if you come across that, what code would you give it?
Poll is open again. Some more seconds. Okay, we're going to close it. A bit of a 50-50 split there between C2 and C3. I suppose with the C2s it would depend on checks, but overall, and with a few little minor tests on it, you could probably do a C3 on that. Yes, first of all, there is no identification of the earthing connection. There's no BS9518 label on it. The conductor itself is obviously smaller than it should be. It's not a 10mm square cable, it's 6mm. It's green, it's not green and yellow. The biggest issue is actually the position of the clamp. It is on the incoming side of the meter. It should be on the pipe that you can see at the top, the outgoing. A continuity check between those two pipes to see if there is actually continuity throughout the meter would need to be done. If there was a continuity check, then C3, and if there wasn't a continuity check, then yes, C2. It's as if it's not bonded, yeah.
So multiple things wrong with that one. Right, so what about you come across this type of thing, for instance? We've got our installation pipes, water, gas, possibly oil as well. However, there's no earth bond to them at all. So if this is the case, what code would you give that?
Polls are open. A few more seconds. It's pretty evident what people are going for. Yeah, okay, closing that one up. Yeah, again, a large majority have gone for C2. Again, C2 is probably the code that I would use, in the fact that we have no earthing to metallic water installation and gas installation pipes without the property. As it stands, touching those pipes will not hurt. If a fault develops and those pipes do become live without proper earthing and the earthing, the protective bonding conductors in place, and the operation, of course, of the protective device, these pipes could remain live and somebody could get seriously injured off them.
Okay, so let's have a look at some examples for code swans then. Now then, examples, the list is endless really. You know, no two installations are the same, and like I was trying to say before, a code 1 is something that, can I touch electricity? And if that's the case, then it's going to be code 1. So access to live parts, code 1. Let's say the board cover's missing, so I can get my fingers in, IP2X. And also, let's say there's unterminated cables hanging from the ceiling, where, for instance, light fitting's been taken down and the cable's just been left with nothing done to it.
Examples of C2. C2, as you remember, is a potentially dangerous situation. Something has actually got to happen to cause a problem, and then people become subject to electric shock. C2, we saw a picture earlier on where we've got line and neutral, and we said it was C1, but that was a multitude of other things. Older cables, cables not protected, access to live parts through the bottom of the buzz bar. If it's just line and neutral double fuse, then C2. We've already mentioned that water, gas and oil pipes need to be bonded. Utility pipe work can be used as the earth and was used as the earth in older installations. And if this is the case, of course, it's C2. We've now got no proper earthing to the building. If there's no CPC for class 1 metal light fittings, the light fitting as it stands will not hurt anybody. If something happens to that light fitting and it becomes live and somebody touches it, then it will. Absence of reliable and effective means of earthing for the whole of the installation. There's no incoming earth at all supplied by the DNO or a reliable TT system. And of course, talking about TT systems, if there's no RCD on a TT system with the high earth fault loop path, the protective devices may not operate within the required time, leaving people open to electric shock.
Okay then, so some examples of Code 3s then. Bearing in mind, Code 3 doesn't really affect the safety of a particular circuit or system. It's just, remember, it's just to bring something up to standards, making it a bit better. So let's say voltage operated circuit breakers then, test button must function, undersized main protective bonding. You know, it is bonded, it might just not be up to the current standard for the size. Absence of RCD protection cables buried within a wall, socket outlet mounted in a way that might result in damage to a plug or flex, absence of labelling with regard to safety.
Here we've got an issue. Obviously, it's pretty evident that this socket is installed within the worktop too close to the surface. There is obviously a damage could be caused to the flex. If this is the case, then obviously we're looking at coding it as a...
Well, I mean, is it causing damage? If it is, then maybe code 2. But in this case, then, as well, this is open for interpretation for yourself to make your own mind up.
C3 probably in this situation, yeah. Regulation 553.1.6 of the regs states that the socket should be high enough to withstand damage to the flex and the plug top. So, a few examples of further investigation codes. As I say, further investigation is not new. They just got coded 1s, 2s, 3s, and in the old days 4s. So they're not new, but these days things like a high ZE, the incoming earth has got a high resistance. Not a lot you personally can do about it, but the customer could get in touch with the DNO, seeing if the TNS system can be improved, moving on to a PME, TNCS system, whatever. There could be an open circuit on the ring. You're testing your ring, lines are okay, CPCs are okay, but you've got a break in the neutral. Quick investigation of the terminations behind sockets do not reveal where the break is. Could be under the floor, could be in the ceiling, could be behind the walls. You can't find it, so again, further investigation. You're there to do a periodic inspection on the property, you're not there to fix it. It would need to be brought to the customer's attention so they can decide what to do with it. Mentioned earlier, and able to identify what circuit breaker isolates. There may be no labelling as to a certain circuit. You ask the customer if you can operate the circuit breaker. It's not evident as to what it's actually isolating. It could be even a bare unterminated cable under the floor. So again, further investigation. And one of the most common problems we have, of course, is in the olden days, neutrals used to be borrowed for upstairs and downstairs lighting, and a borrowed neutral can cause problems when isolating, especially to the uneducated that don't check things are alive or dead, and therefore isolating one circuit, you could still get a little bit of a backfeed on a borrowed neutral and get an electric shock. Again, further investigation.
Okay, so some other problems that are quite common out there is when they've earthed or bonded to the main service cable. So as here we can see we've got like an earth clamp and some sort of makeshift clamp maybe that you've come across. So what do you think about this? So is it a proper termination? Well, no, it's not. Is it something that we can sort out ourselves? Well, we're not to do that because it's the service cable that's provided by the DNO. So what we need to do is contact the DNO and tell them it's not adequate and could they please make it better.
Other pictures that members send in sometimes can be rather amusing. The fan being installed on the floor really may be a very, very well installed electrically installation. What does come into mind here is that whoever did install that fan really hasn't got really much idea when it comes to Part F of the building regulations and how ventilation works and everything else. So again, although Part F is not under periodic inspection regime, so to speak, it would certainly, in my mind, need bringing to the customer's attention that this is not an adequate way of ventilating a toilet.
Now then, the burning issue then. Remember why we had the Third Amendment. It was there to make consumer units non-combustible. And why was this? It's because should there be a problem inside of that consumer unit, it was hopefully that it didn't add fuel to the fire. It was because it was the enclosure that was catching fire, which was the fuel for the fire. So if we took that fuel away by making it metal, then it got rid of that problem. So it is very, very important then to make sure that when we're inspecting and testing our installations, that all of those terminals are nice and tight, that there is no visible sign of overheating or damage or burn marks in there. And so if everything looks nice and clean and put together well and everything's tight, then there's no need to give anything a code here. However, should you find that there has been some sort of arcing or some sort of burn marks, then there is need for some action.
Don't forget the inspection schedule asks about your consumer units, distribution boards, and you would be ticking the inspection to stating that you have checked it. In summary, anybody carrying out a periodic inspection needs to be a skilled person. They need to be competent in the electrical installation they are inspecting. To go into a industrial premises and try and do a periodic inspection on that when all you ever do is domestic, then sometimes that's a bit out of your scope. EICR is an assessment carried out against the requirements of today's current edition of BS 7671, which includes the Third Amendment, with recommendations as appropriate to the installation's use and how the external influence is exerted upon it. It is entirely a matter for the inspector carrying out that periodic inspection to decide on the recommendation code of any particular observation. Many thanks for your participation in our webinar again. We do have a few questions. We'll have to just say, unfortunately, we do apologise for a few technical issues. First of all, in the lateness of the webinar, but because of a few technical issues and a few issues as well, we couldn't get our usual presenter on to introduce us properly, so you had to do with us. But Gareth's going to read out a few questions and maybe we can both answer them and see how we go.
Okay, so a question from one of our members is, what would the code for sockets in a classroom be with access to outside with no RCD?
No, that's a good intro. Yeah, with a classroom, personally, you would have to have a C2. You've got to make it that a C2, in my opinion.
Well, yeah. I mean, if we're going to be using equipment outside,
yeah,
then
I'm plugging it into the classroom.
Yeah, and you're going to plug it in. Then yes, absolutely, it's an RCD.
You've also got to remember that because the word classroom is used, we have maybe children that could be using it, people of a certain age that don't understand the risks yet. Unfortunately, students being students, if they can plug something in to get a supply to mobile phones or their iPads or something like that, yeah, they'll plug it in. So to me, yeah, RCD protection, definitely.
Okay then, so it appears that someone's done an inspection recently and they've come across that an inspection carried out 5 years ago with numerous code 3s identified. The landlord has not rectified any of them, so these all exist still. There are no C1s or C2s picked up. Is this still satisfactory? Well, yeah. Well,
I was going to say, yeah.
yeah,
C3s are satisfactory. So.
if the C3s, does it impair safety? Then no. Is it still satisfactory? Yes, it's still satisfactory. But what I would do is, if there are lots of C3s, just be a bit more thorough and inspect them, just to check that they aren't actually any C1s or C2s in that installation. However, you can't force somebody to upgrade those C3s.
Yeah, my problem with that is, if the landlord 5 years ago had somebody in to do a periodic inspection and he had that many C3s identified, what did he ask you to go in the first place for? That's my problem, because he's obviously not taken the advice of the electrician involved, and he's certainly not taken any sort of duty of care towards his tenants.
Right, so another question then. Let's say someone's come along, they've done a test of their ring final circuit and they've found that there's no ring continuity on the live conductor. Would this be a C2?
I think we explained this one in the presentation. We've got that down as a further investigation, in the fact that the break in the ring probably couldn't be found. It could be within the fabric of the building. Probably in my day it would have been a C2. It still fails. Obviously, a further investigation or a C2 will still be an unsatisfactory verdict. What you've got to remember is, if it's a ring, it's a 2.5 cable. That 2.5 cable with a break in it is two 2.5 cables rated at 27 amps on a 32 amp protective device, and therefore could potentially be overloaded and cause a problem before the protective device operates.
Okay, let's say we've come across an installation. It is not being inspected and tested regularly. Do we need to do a 100% inspection?
Personally, yes, I would suggest so. You've got no paperwork, previous documentation, previous circuit results, test results to work to. You are turning up on an installation with no information whatsoever, so you are going to be doing a lot of exploratory work anyway, checking that what is labelled is actually doing what it's supposed to do, and really you'd be starting off with a 100% inspection on the first time, and dropping it down maybe to a 20% check, as long as you've got documentation to sample to.
Okay, so this one looks like someone's done an inspection and test recently. They've come across a socket that was installed before the 15th edition on a unaltered circuit, so nothing's happened in many years. Is it still is it a C2, even if it can be used for outdoors equipment?
Let me just read that one. How can a socket?
So how can a socket installed before the 15th edition on an unaltered circuit be a C2?
It's probably
even
not.
if it can be used for outdoor equipment.
If it can be used for outdoor equipment, it would definitely be a C2, because equipment taken outdoors, the body resistance is lower, the chances of problem electric shock are greatly increased outside the equipotential zone. So yes, C2 if it can be used outdoors. If it can't be used outdoors, and there's no evidence of damage to the circuit, it looks fine, no damage to switch drops, socket drops, then to me it would be a C3.
Yeah, I mean, like you say, yeah, I agree with that. You know, if it's just used indoors and it's not supplying equipment outdoors, then it's not really a big issue. But if it is supplying things outdoors, even if it is to previous edition regulations, end of the day, what are we putting that RCD there for? Is to protect the users. So if we're outside, like you were saying, there's an increased risk. So if that is there, then it must be an RCD. So if there's not one, then yes, absolutely C2. Yeah. So here's another question then. Domestic consumer units generally have lids which cover the MCBs. So if the lid was missing, would this just simply be a non-compliance?
If there's no labelling and the lid was used for the labelling of the circuit breakers or the fuses, like in the old Wilexes, for instance, then that would probably go down as a C3, in the fact that you can't see what you're isolating. Older Wilex boards did have a very good gap around the fuse carriers and things, so you know, insertion of tools and things could cause a problem. I think it would be down to whether you could actually get a contact with a live part in any way, shape or form as to what code I would give it.
I mean, to me, I think what I'm understanding here is that the flappy lid on the metal consumer unit, if it is that and the flappy lid's gone missing, I mean, to me, the flappy lid is just to make it look pretty.
It's just a flappy lid, yeah.
So, you know, if there's no risk to danger there, it's not even a compliance. It's just to make it look nice, I think.
Yeah. It might be just worth putting it down as an observation that the lid's missing, but there is no evidence that there could be any contact with live parts.
So then, it says here, do we need to code meter tails longer than 3 meters?
The answer to me would be yes, you would. It would be a C2 because there's no protection on those tails.
Yeah, it's all about the protection for those cables.
Yeah. If those tails can be damaged in any way, shape or form, between the cutout, the meter, and the consumer unit distribution board, then obviously the only backup is the supply authority's main fuse, and they will only guarantee it for a 3 meter run. C2.
Right, okay, so let's say you come across some undersized bonding then. Let's say the structural steel, the bonding is there, but it was undersized.
C3.
C3.
I think, yeah. There is bonding present. Large industrial jobs with a very small bonding conductor, I think you would need to take an exception at that and probably code it as a C2 in the fact that it might not take the fault currents that could be evident in industrial situations, but within a domestic situation, the old 6mm, again, as long as you can't find any thermal problems at the terminations, would to me be just a C3. Yeah.
Right, okay, well thank you for your questions this evening. I hope you enjoyed our presentation tonight. However, we've come to the end of our time.
Yep. We do again apologise for the technical issues. Hopefully, for the next one, we can certainly iron out what has been a bit of a stressful evening. But never mind. Thank you for turning up to our webinars. Please, if you would, please complete the survey. We'll be leaving the system open for a bit so people can download handouts and the likes and the certificate. Obviously, future webinars will be announced on the online forums, over social media, via emails. Please keep your eye out for these. Once again, many apologies for problems. Thank you for your time. Do enjoy the rest of your evening, and we'll see you again soon. Goodbye.